Hey guys, what's up everybody? Welcome or welcome back to another exciting video from the Apex Academy of Mathematics. We're learning the language of the universe begins here. And in this video, we're going to be talking about simultaneous equations and solving them using two different methods, the elimination method and of course the substitution method. All right, my name is Akin, otherwise known as Apex Selenium, and of course if this is the first time here on my channel or you've watched previous videos before, of course please go ahead and do me the pleasure of dropping a like on this video, and of course smashing the subscribe button, and of course turning on your post notification bell for future tutorial videos. All right, I also want to make I want to use the opportunity here to let you know that I'll also be doing a little bit more for students as it relates to mathematics, because in the time of recording this video we are actually in a pandemic where of course we are doing a lot of online classes, so a lot of students out there do need a lot of help or additional help with topics that are of course a little bit more of a complexity for them. So of course I want to go ahead and start some live classes for CSEC or CXE, CAPE math, additional math. Of course I want to do something for the university students also, for college algebra and for pre-calculus too. So do look out for those live classes. Link will be placed in the description below for the channels. I do have another channel that I'm working on at the moment, but I'm not ready to let you know about it as yet. But for now, most of the videos and the lives will be done here, so please join me if it is that you're doing CSEC, and of course please go ahead and of course share this video with anyone out there who you do know. All right, but for this video specifically, we want to clear up some misunderstandings, some misconceptions, some ambiguities when it comes to solving simultaneous equations. So of course if you are comfortable with what I'm about to do right now, and of course what I've done before, I'm improving on my videos, drop a like on the video, of course smash the subscribe button as I said before. So without further ado and any rambling, let's jump right into this video. All right, so as the title suggests, as you can see here right on the screen, that we're going to be talking about solving simultaneous equations. All right, now this video will be done in two parts. Part one will be the elimination method, where we're going to be going through a comprehensive discussion, all right, about solving simultaneous equation. It might be a little bit of a lengthy video, but of course do not watch this video in time when you rush. Make sure you watch this video when you have time, you have a pen and paper out to understand the concept. After this video, I really do believe that you're going to master your ability to solve any simultaneous equations. All right, so please of course stay tuned and watch this video to its entirety. Okay, all right, so I'll try to be as concise as I possibly can. So let's jump into it. It says here right at the top that a pair of simultaneous equation has a special appearance, all right, which is in the form of, as you can see here, ax plus by is equal to p, and cx plus dy is equal to q. Now it says here that where a, b, c, d, p and q are all integers. A link is in the description below for a video that I've created about integers, so do check that out. All right, but as a reminder, integers are basically positive and negative whole numbers. So these numbers a, b, c, d, p and q could be positive numbers, it could be negative numbers, including also 0. All right, so definitely make sure that you understand that. Now to be specific, a, b, c and d are called coefficients. They are called what? Coefficients of the variables that are in the equation. Now at the moment, looking at this this thing that I've designed here for you, these are all variables: a, x, b, y, p, q, d, y, c and x. They're all variables. But once you replace a, b, c and d with numbers, then the only variables that are there are going to be x and y. So basically a, b, c and d are all coefficients of the variables x and y. It is x and y that we're going to be, of course, trying to find the values of. Okay, that will give us the end result of p and q. So hopefully you can understand what that means at the moment. All right, good. Now also I want to mention to you that this here is an arrangement of linear equations. Okay, so this is a linear equation with two unknowns or two different unknowns, this is a linear equation with also two unknowns. So when two linear equations come together, we are expected to solve them simultaneously. All right, let's jump into this part here that talks about what simultaneous equation technique is. Now it says here, simultaneous equation technique of solving for unknowns is especially used for solving two unknown quantities in the same problem. All right, now I need to make reference to something that I've always been taught, or it has always been said to me, and over the years I recognize that that's not really the way how it ought to be said. Now the word simultaneous means at the same time, but the question to you that I have is, can you solve two problems really at the same time? I don't think that's possible. Simultaneous equation is not solving for an unknown or unknowns at the same time, but is solving for two different unknowns in the same problem. All right, so the word simultaneous means same, but it doesn't mean at the same time. Okay, so if you're going to do something simultaneously at 10 o'clock, then you're going to be doing that task at the same time, 10 o'clock. But if I'm going to be solving a mathematical problem, a simultaneous problem, I can't solve for x and y at the same time. I have to solve for one, then the other. But it so happens that x and y, which is the unknown quantities, are in the same problem. So just to make it that clear that you cannot solve for an unknown quantity or unknown quantities at the same time, but you can solve for unknown quantities or two different unknown quantities in the same problem. All right, so I wanted to make that clear for you. Another thing that I want to highlight is that the fact that the application of simultaneous equation doesn't stop here. When you learn it here, it's just an introduction. It goes on up to the highest level. All right, so you're going to be using it, of course, in CSEC, in CAPE, in additional math, college algebra, pre-calculus 1 and 2, calculus 1, 2, 3, 4, all other applications of math. Simultaneous equation is needed because there's going to be scenarios where you have two problems in the same question or two quantities in the same question that you need to solve for, and this is the only technique, of course, that we can use to do and complete that problem. All right, so its application doesn't stop here. Now there are different ways that simultaneous equation can appear. It can appear in where you're given the equations, like for example, I've written the equation over here for you. This equation was given to us. Yes, it was given to us. But of course, there are scenarios that can be created where, of course, typical scenario for CSEC or at any problem in math is that, hey, let's say Adam went to the store to buy milk and cookies. Adam may have bought 2 milk and a box of cookie for $50. But the scenario is that what if he had bought 4 boxes of milk and 2 cookies, he would have paid a certain amount of money for each situation. Then we have to use those information given to us to, of course, then solve for the cost for a bottle of milk and, of course, a box of cookie. All right, so there are different situations which can be derived for simultaneous equation, but for this video we're just going to be going through the whole process of applying the steps. In future videos I'm going to be making that's going to be talking about worded problems involving simultaneous equations. So for now, just work on building your fundamentals in this. All right, now of course there are two methods that is most useful when solving a pair of simultaneous equations. Of course, the method that we're going to be going through in this video, part 1, is of course the elimination method, but it's also a subsequent method called the substitution method. All right, we are going to be going through that later on. All right, so that is going to be in part 2 of this series. All right, so I've chosen this question here for you. All right, and rather than like other videos on YouTube, take a question, work it out, and work it out from beginning to end. I want to take the question, and in each step that I've created here for you, I want to show you exactly what should be done and what it should look like. Okay, so that's what I want to do. Now, like everything else in math, there is of course a couple of steps that you must follow. Math is a procedural topic. All right, it's a procedural subject, it's a procedural language. You must follow step 1, step 2, step 3 to get to your answer. So like everything else, it strategy is important, steps are important, and of course we're going to be going through that as it relates to this here. Okay, so there are indeed a couple of steps that are required to easily and of course effectively solve any pair of simultaneous equation regardless of the coefficient, the numbers that are given here, whether it be decimals or it be fractions or it be integers. These steps will hold true. All right, so we're going to get into it. So let's look at step 1 here. The first thing that you want to do is to give your equations a name. It's almost like when a baby is born, the first thing you think about is, what's this baby's name? What name am I going to name this baby or name this child? All right, so the same thing here with math. Given an equation, you want to give it a name. Now, I use 3 different types of indicators. I use EQ1, I use ... 1, or I use ... A. All right, you can use whatever letters you want. You can say equation C and equation D, equation X and equation Y, but I just generally like to stick with stuff like this. I mostly, of course, as I said, I mostly use this kind of indicator here, this ... 1. So that's exactly what I'm going to be doing here. So since I've already written my equation up here, I'm going to go ahead and I'm going to name my equation. I'm going to say, hey, let's zoom it up for you here. I'm going to call this here equation 1, equation 2. All right, and that completes my step 1. I've named my equation, so I know that the top equation is equation 1 and the bottom equation here is of course equation 2. So that completes my step 1. All right, guys, so if you got that so far and you're understanding the concept and you're enjoying the video, of course, please don't be afraid to drop a like on the video. Okay, all right, let's continue. Step 2, select a variable that you wish to equalize its coefficient for elimination. I really want to stop right here and go through what that means. It says here, select a variable that you wish to equalize its coefficient for elimination. So basically step 2 here is like a selection process, right? It's just, do I choose the X variables to eliminate or do I choose the Y variables to eliminate? Now, to highlight this, let me let you know that of course a lot of teachers will teach you and tell you that always you must eliminate the middle term, but that's not always the case. Of course, you can experiment by eliminating the X terms. I'm going to be going through some examples, of course, on the next page, where I'm going to be showing you that eliminating the X or the Y does not change your result. You can eliminate the Y to first find your X value, or you can eliminate the X values, the X variables to first find your Y value. So eliminating one to find the other does not make a difference to how you're going to be doing it. All right. Now, as I mentioned to you before, the 3, the 4, the 5, and the -2 are called coefficients. So your objective in this selection process here is to choose what I would safely say the easiest one. All right, I like to choose the smallest numbers. All right, so what you want to do here is that you want to choose either the Y's or the X, and you want to make these 2 numbers become the same. Let me just zoom this up for you. You want to try to find a way how to make the 4 and the 2 become the same number. Or if you choose the X to eliminate, you're going to choose a final number that you can make 3 and 5 become the same. Now, there's a couple of ways that you can actually do this. A lot of persons that are experienced will look at this and know exactly what number to choose. For example, I will know right away that if I wanted to equalize to make the 4 and the 2 the same, I would just let this number remain as 2 by multiplying this equation by 1, and I will just multiply this equation here by 2 so that this number becomes 4. That you can do with experience. If I wanted to equalize the X's over here, I know right away that if I wanted this to become, these numbers to become the same, I would just multiply this by 5, this equation by 5, and this equation by 3. But for you students who are watching this for the first time and you've always had a problem with simultaneous equation, there's of course a couple of techniques that you can use. And one such technique is of course what I refer to as the coefficient interchange technique, or the Lca method. So the first thing I want to do is that after I've chosen my variables here, let's say that I am the student that's learning for the first time. What I want to do here is that I want to look at the number 4 and 2, and I want to find the LCM of 4 and 2. And when I know that the LCM of 4 and 2 is 4, then what I'll do is that I'll think about the fact that how can I let this number remain as 4? Since the LCM is 4 and this is already 4, I want this to remain as 4. And the only way to have this remain as 4 is to multiply by 1. And then now I want to think about how can I make this number become 4? Or make this number here, forget about the sign for now. How can I make this number become 4? And the only thing I can do here is to multiply by 2. And that's what I talk about, that's what I refer to as the Lca method. Now the Lca method will work all the time. Yes, the Lca method will of course work all the time, but however it sometimes will give you some bigger numbers than you ought to. It will not necessarily make the problem harder than it's supposed to be, but it will just give you some numbers that are usually very bigger than you ought to have to work with. All right, but that can work in terms of choosing the numbers that you multiply by. Now also I want to make a note that not only are you multiplying the term that you've chosen by the numbers over here selected, you're multiplying the entire equation by that number. So you're multiplying the 3x, the 4y, and the 11 by that number, and you're multiplying the 5x, the minus 2, and the 1 by that number. All right, so you want to make sure that you understand that concept. All right, so here you can also use the interchange technique, the coefficient interchange technique. So what that does is that, hey, I look at the fact that I want to equalize this number here, these two terms here, this variable here, the coefficient of these variables here. So I say this is a 4. I could simply multiply equation 2 by 4. All right, if I wanted to. And of course, this is a minus 2. I can multiply this equation here by minus 2 if I wanted to. All right, so again, that will give you some numbers that are bigger than it ought to be, but regardless of the fact, the objective here is of course to get these two numbers to become the same. All right, so I hope you guys got that, I would say rather elaborated explanation of how to choose your numbers, but my main objective here is to make sure that you understand the selection and the selection process. Now, in order to equalize the coefficient, as it says here, is to choose variables, special numbers that can be selected randomly or using. Okay, so I've just went through that for you. All right, so we're going to, of course, jump to the step 3. All right, so before I do that, let's go ahead and choose our numbers. So I'm going to eliminate the middle term in this example here. So I'm going to, of course, go down here and I'm going to say, hey, 3x plus 4y is equal to 11. That's equation 1, and I'm going to multiply that equation, of course, by 1 because I want this to remain as 4, and I'm going to have 5x minus 2y is equal to, of course, 1, and of course I'm going to say this is equation 2, and I'm going to multiply this equation by 2. Let's zoom it up a little bit for you here. Okay, all right, good. So now I'm going to do the multiplication part. So 1 multiplied by this entire equation, that's the, of course, multiplicative identity, will give you back the same equation. So that's going to give me 3x plus 4y is equal to 11. And that becomes equation 3. And then I'm going to multiply this equation here by 2. So that gives me 2 times 5x is 10x. 2 times 2y, or 2 times minus 2y is minus 4y. And of course 2 times 1 is going to give me 2, and that becomes equation 4. So I've completed my step 2 there. So these two equations down here are new equations that I'm working with. So I'm going to go right over here and I'm going to find some space here to rewrite those two equations. So I'm going to move this down a little bit to create some space. So here I'm going to rewrite this equation here. 3x plus 4y is equal to 11. So 3x plus 4y is equal to 11. And I have 10x minus 4y is equal to 2. 10x minus 4y is equal to 2. So these are the two new equations I'm working with. All right. So once I've completed that, I'm ready to move on to step 3. So now that our chosen variables have equal coefficients, all right, equal coefficients 4 and 4, minus and plus. We need to decide whether to subtract or add the chosen variables for complete elimination. All right, so now that we have this, we need to decide, should I add equation 1? Should I add equation 3 to equation 4? Or should I subtract equation 3 from equation 4? What do I do? The steps here are written in red and of course in blue here for you. So it says here, if the signs of the chosen variables are the same, we will subtract all the terms of both equations. In this case here, we are thinking about equation 3 being subtracted from, of course, equation 4. Okay, that's if the signs are the same. But here, we recognize here that this is a plus and this is a minus. So, of course, the signs are not the same. So it totally contradicts what we need to do here. In blue, it says that if the signs of the chosen variables are opposite, then we're going to add all the terms of both equations, which in this case here is equation 3 and equation 4. Right? So we see here that the signs are different. So we're going to be adding equation 3 to equation 4. So I'm going to be adding this term here that is in equation 3 to this term here that is in equation 4. So that's 3x plus 10x. That's going to give me 13x. I'm going to be adding this 4y to this minus 4y. So when I take 4y and I add it to minus 4y, that looks like the additive inverse identity, and that will give me 0. Hence why it is called the elimination method, because the objective here is to eliminate the variable so I can solve for the other variable. So 4y plus minus 4y gives 0. And of course, here we have 11 plus 2 is equal to 13. All right. Now we are going to simply do division both sides of by 13. So we're going to divide here by 13 and divide here by 13. And we're going to get here nicely that x is equal to 1. All right. So we have solved for our first unknown. X is equal to 1. All right, good. So as I said here, hence why this method is called elimination method, because our objective is to get rid of one of the variables so we can solve for the other. So x here is equal to 1. So I hope you guys got that part. Now we're not finished yet with this example, so let's create some space here for you. Let's erase here. All right, so we've noted that x is equal to 1. So now I'm going to just move this information up here so we can see clearly. And now we're at step 4. Step 4 says that we're going to be what? Solving the linear equation to find the first unknown, which is what we just did. We just solved the equation and we found out that x here is equal to 1. So what we're going to be doing here is that we're going to be replacing that value that we got, x is equal to 1. We're going to replace that value in either of the first two equations that was first given or created. So if you go back to this page over here, the equation that was given to us here was 3x plus 4y equal 11 and 5x minus 2y is equal to 1. So it doesn't matter which equation we choose to replace the x with. I generally like to choose the smallest number and to avoid the equation with a minus, all right? Because this example is quite easy. We're working with positive numbers, but there are cases where sometimes the equations have all negatives all over the place. It becomes really difficult, especially if your signs are a problem. You can check out the links in the description below for videos on multiplication and division of signs, so that if that's a problem you can work on that too. So for this one, I'm just going to basically just use equation 2 here. No special reason, but I think the numbers are a little bit smaller and easier to work with, and that's just personal preference. All right, so I remember that. Let's make a note here that x is equal to 13. X is equal to 1, pardon me. So we're going to do that. So we're going to choose 5x minus 2y is equal to 1. I believe that's what we had over here. That's correct. So anywhere I see an x, I'm going to put a 1. So I'm going to have 5 times 1 minus 2y, that's going to give me 1. All right, so 5 times 1 is 5 minus 2y, and that's going to give me 1 here. All right, so I'm going to do a little bit of algebra here. Just bring the 5 over to that side. So I'm going to have negative 2y, okay, is equal to this 1 over here. And when this 5 goes over to the other side, this positive 5 here becomes minus 5. All right, so now what I have now is just simply negative 2y right here, and that's equal to, when I evaluate that, I'm going to get negative 4. All right, so if I divide both sides by minus 2, all right, let me just write that in a different line so you all don't get confused. So we have minus 2y divided by minus 2 is going to give me minus 4 divided by minus 2, and when I cancel that out, I'm going to get y is equal to negative divided by negative is positive, so 4 divided by 2 is going to give me 2. All right, so I've got my answer here to be y is equal to 2. All right, and that really brings us to the end of the problem. Really and truly, it doesn't get any harder than this, all right, as it relates to simultaneous equation. So I took a different approach in terms of how to work out the question. Rather than taking a question and work it from beginning to end and have explaining steps by step, I rather to do the step and then show you exactly what needs to happen. All right, so I hopefully you guys got that part. All right, hopefully you guys got that part. I do want to also make a note that, of course, after finding your values of x and y, it's normally a procedure for us here to simply tell you to record your final answer at the end of your solution sheet in a little box for full marks. So you want to say, therefore, x is equal to 1 and y is equal to 2, and put it in a nice little box at the end of your solution sheet. All right, a lot of teachers like that, and a lot of teachers, including myself, like when a student do that at the end. X is equal to 1, y is equal to 2. All right, so of course, guys, I do have some examples here for you, but I'm of course going to upload another video going through simultaneous equation examples. So I'm going to be posting another video on this, so look out for it and make sure that you tune in. We're not going to be seeing the words or the explanation. We're just going to be running through these steps. So make sure that if you're watching this, if you're watching the elimination method example first, make sure that you watch this video to its entirety to understand how it's done. All right, and then following that, of course, I'm going to have a video on how to use the substitution method. As you can see here, I'm already prepared for you. Okay, all right, wonderful, guys. So without further ado, I want to say thank you for tuning in to the end of this video, and of course, I hope this was a benefit to you. Thank you so much, and I'll see you next time in another big bad tutorial video from the Apex Academy of Mathematics. Do take care. Until then, bye bye.